For your information, there's a lot more to ogres than people think.
Example?
Example? Okay, ogres are like onions.
They stink?
Yes. No.
Oh, they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white hairs.
No. Layers. Onions have layers. Ogres have layers. Onions have layers. You get it. We both have layers.
Oh, you both have layers. Oh. You know, not everybody like onions.
Okay, we're going to be talking about layers of the earth. And when we do this, we want to talk about the fact that the layers are broken up into two different categories, whether we're talking about their chemical composition or their physical properties. And as we go, if we take a look at the chemical composition, it is broken up into three layers. It's broken up into the crust, the mantle, and the core. And when we talk about chemical composition, I'm not expecting you to understand what the chemical composition is, but I need you to understand that there are three distinct chemical variances as we take a look at it. The outermost layer, when we talk about chemical composition, is going to be the crust. And there are two types of crust. There is oceanic crust and continental crust. And if we take a look at oceanic crust, it is going to be mafic, and that is going to be more basalt. It's going to be more dense and darker. Continental crust is going to be felsic. It is going to be more feldspar and less dense and lighter in color. So we have oceanic crust, mafic, dark, and dense, and we have continental crust, felsic, lighter colored, and less dense. Okay. Then we have the mantle. So this here is our crust. Continental crust and oceanic crust. Continental crust is usually much thicker. Oceanic crust is usually much thinner. Underneath that is the mantle. And the mantle is that slow flowing solid rock. It moves, doesn't move fast. Okay. And this is where convection takes place. And this is something that we are going to be working on understanding the best we can, that we have convection currents taking place in the mantle. Once again, not fast, but it is happening that we have convection taking place in the mantle. And underneath that, we have the core. And when we talk about the composition, at one point in time, the earth was all liquid, and the more dense elements went down to the middle, because that's where the gravitational pull was the greatest. And that's where we have mostly iron and nickel. So we have the crust, the mantle, and the core. And as you go down, each layer is going to be more dense because it's going to have a greater density. If we take a look at physical layers, these are a little bit more complicated, but if we take a look at the physical properties, we have either a solid or a liquid. And once again, the concept of a liquid is going to be liquid-like. It's not like necessarily water. So our first layer is going to be the lithosphere. And the lithosphere is going to be the solid. It's going to be made up of the crust and the rigid mantle. So a little bit of the mantle and all of the crust. And this is where we will have what's called our tectonic plates. These are the solid things that move on top of the asthenosphere. Okay, so that very outermost one is lithosphere. Then we have the asthenosphere or the asthenosphere, and this is going to be the liquid mantle. And that is in here. This is where we are going to be having our convection taking place. And it's as we go down, it's going to be hotter also. And this is the area in which the tectonic plates float about. And float is a bad term, moves about. Okay. Then we have the mesosphere. And here's the mesosphere. and it is part of the mantle. We're still talking mantle if we were talking about chemical, but this is going to be rigid. And once again, rigid is not necessarily rock hard, but it doesn't move as fast. So these are going to be physical characteristics. So the lithosphere is going to be liquid. Is going to be solid. Then we have the asthenosphere, which is going to be liquid. Then we have the mesosphere, which is going to be solid. Then we have the outer core and the inner core. And these two cores line up the same with our chemical composition, except the outer core is going to be liquid. That temperature has increased so much that the iron and nickel is actually liquid. Then we have the inner core, which is still hot, but it's now a solid. So if we take a liquid, and if this is our liquid model, those molecules are moving about, and we push them so close together, they are going to act like a solid. So the outer core is going to be liquid, the inner core is going to be solid. And my stupid way of remembering the lithosphere, asthenosphere, mesosphere is a lamb without the bee. So lithosphere, asthenosphere, mesosphere. And it goes solid, liquid, solid, more solid than liquid, liquid, solid. So solid, liquid, solid, solid. Okay, so that is layers of the earth for today. Have a great day.